Welcome, dear learners, on this video session on data organization. By now, you must be clear about what is statistics. Statistics is a subdiscipline of mathematics, and if we give a quick recap, you must now be aware about statistics, about sample, population, parameter, statistics, and so on. In this video session on data organization, we are going to see how data is organized and what is the usefulness, how it is organized, because if we have a lot of data, actually it is meaningless. So we need to organize the data in a useful manner so that it gives us some meaning. So data is the plural of datum, and it is a Latin word for the collection of information. So we have a lot of information in data. So now we are having data analysis, data analytics, and so on. So if we do not organize it properly, it will be meaningless. So the basic idea behind any statistical inquiry will be to describe and understand the population of interest. So whenever data is collected, whenever information is gathered, we always have some population in mind, we have some sample in mind on whom we are collecting the data. For example, you must have come across so many reports, like for example, the WHO report, the National Health Family Survey, United Nations report, and so on. So they collect data and then it is organized and represented graphically also. Otherwise, it will be meaningless. We have exit poll surveys also. For example, before the election, the exit poll is conducted, and from the probable voters, questions are asked and on that basis, it is concluded who will be leading, who will be following, and so on. So we see how the data is collected on one hand and then how it is organized to give some meaning. Now let us explore more. So in order to organize the data, it is very important to classify and tabulate the data, right? So data can be both qualitative and quantitative. Quantitative data, of course, as the name suggests, it is on a numeric scale. For instance, height, weight, temperature score on an exam. So this is discrete. And while as qualitative variables or the qualitative data, it involves ordering or measuring, and this is categorical variables like the favorite color, the texture of hair, etc. Now both are important when we are collecting information. So for example, whichever information we are gathering, we are collecting, we tend to classify. Even the human brain receives information like that and classifies it for better memory. Just for an example. So in a similar way, classification here is also, it is very important for the information to be in an ordered and in a concise manner to give it more meaning. And it helps the researcher in both descriptive statistics and inferential statistics. So by now it must be clear about what is descriptive statistics, what is inferential statistics. Descriptive statistics, of course, there is no generalization, and we, for example, we use the measures of central tendency, we classify and tabulate data, and there is no generalization, while as in inferential statistics, for example, we tend to measure the differences and so on, where we can infer and generalize, that is the inferential statistics. So for both these kind of statistics, we need classification and tabulation. So now let us see the significance of classification. For example, the data becomes more organized, as I just mentioned, it becomes concise, well planned, because whatever the information that is collected, that is the raw data that we say as raw data, that is meaningless. And in order to classify it, in order to organize it meaningfully, we need to place it in homogeneous categories. And this homogeneous groups, they are as per some common characteristics, and these are as per some kind of a similarities. For example, the students getting marks between 80 to 90. So this is all the students getting marks in between will fall under same category. We have, say for example, division of marks, like first division, second division, third division. So anything above 60% first division, anything between 45 to 60% is second division, and so on. So there is some kind of a homogeneity, there is some kind of a similarity or a common characteristic that of course the researcher needs to identify. After classification, when classification is done, of course statistical analysis can be planned. We will in the forthcoming sessions, we will be talking about statistical analysis. It also helps to draw conclusions. On the basis of classification, you can conclude about some meaning that comes out of, some kind of that data. Comparisons can be made, similarities and differences can be identified. So definitely we can compare, like for example, how many students have scored above a particular score, or how many of them have performed badly, and so on. So the similarities and differences can be identified on the basis of this, and comparisons can be made. Say for example, let us take in this marks obtained by students, and then we have marks, we have categorized it, we have classified it. Say for example, 11 to 15 or 16 to 20, 21 to 25, and so on. And we know the number of students who fall in this category. So we can, now this is classification. So now it is so easy to conclude that the maximum students are falling in the category of 31 to 35, because 14 students are there in this category. Following is 36 to 40. So now it becomes more easy for us to come out to see the similarities, to see the differences. We can compare that, like for example, there are less number, in fact, the tapering. 11 to 15, only 2 students, and 46 to 50, 2 students. So many comparisons, similarities, differences can be worked out on the basis of classification. Similarly, there is another concept of tabulation in statistics. Tabulation is very important. You must have come across so many reports, for example, the Economic Survey, the Census of India, and so many other reports like the WHO, United Nations, and so on. The data is tabulated. It is in a tabular form. It has rows and columns, right? And you always have a table number, title of the table, captions and stubs, body of the table, head note, footnote, data source. Even if you come across any kind of a research report, any kind of a dissertation, any kind of a research article also, which has a table, you always see that there is a table number to it, right? There is a title. See, we will see, for example, here you have a table number, say X, right? And then there is a title. There is a title to it. Say, for example, this is the marks on an English test. Then on the left hand side, you have the stub. So stub are the captions on the left hand side of the table. We have gender. This is as the caption head. Again, you have about, on the basis of gender, how many categories you have made here. We have made it as males and females. So N is the total number of samples, say 50 in both the categories. This is the caption. And then the percentage follows, and at the footnote, the number of students in terms of the percentage as well as the source from where this data is coming. Say for example, we tend to quote many a times the Government of India data or the WHO data. So wherever we are taking the help of these tables, we always cite the source. So that source will come, say for example, Census of India 2011, and so on. So this is just an example. So what is this table doing? This is trying to simplify, it clarifies, comparisons can be made, and it is easy to refer. So that is why tabulation is an important part of data organization in statistics. Now there are few important aspects where in tabulation, it is the construction of frequency. When we say construction of frequency distribution, there are mainly three types: the relative frequency distribution, the cumulative frequency distribution, and the cumulative relative frequency distribution. So in the relative frequency distribution, the score allotted to each class interval is in proportion to the number of cases in that distribution. In the cumulative, it is the summation. Cumulative is always the summation of whatever is there. So it is the summation of the frequencies of that class interval and of the class interval below that class interval. So we'll see how the cumulative frequency is calculated. So it is the summation of the frequencies of that plus the frequencies of the class interval that is below that class interval. And the cumulative relative frequency distribution is the score is the relative frequency for that score in summation with the relative frequencies of all the scores that lie before this particular score. So we will, when we calculate, it will become clear how all these are little different from each other but are important aspects of construction. So for example, here we have the scores and the frequency. So the scores are given and the frequency is given, and then the total is given. Now we are going to calculate the relative frequency. So relative frequency is calculated, and the cumulative frequency and the cumulative relative frequency. We are going to calculate on the basis of, for example, we divide the values into intervals and then count the number of values in each interval. Say for example, here 19 is the lowest and the frequency is 7, and accordingly the relative frequency is calculated. The cumulative is 7, then 7 plus 6 will be 13, 13 plus 10 will be 23, 23 plus 4 will be 27, and 27 plus 3 will be 30, right? So accordingly, we will be calculating the cumulative relative frequency. The topmost will be 100%, and that includes all the 30 frequencies. Percent is always in terms of 100. So that is 100% on top, that is 30, that is the 30, the total n is equal to 30. We also have the computation of ungrouped frequency distribution. We also tend to compute the ungrouped frequency distribution in a way, for example, with the help of tallies. Tallies are, for example, we make a strike like this, a slant, where we are going to count the number of frequencies. So, for example, 0 marks. So there is only one candidate. So here we are going to put a slash, that is frequency 1. Similarly, if 1 mark, there are 2 candidates, we are going to put across 2 tallies. Similarly, in 2 we don't have any candidate, it will be 0, so no tally. And if it is more than 5, so we are going to write, we are going to put 4 tallies and a cross across. And then, for example, here in the 5 marks we see the frequency is 9. So 4, then the tally is put across, and then that is 5 and plus 4, that is 9. So this is of the ungrouped frequency distribution, right? So this is, and again the total, the summation is 30. So this is how we are going to put tallies for an ungrouped frequency distribution. We also have, in a similar way, we can also compute frequency distribution on the basis of groups. So we have categorized here as these categories are there: 1 to 6, 7 to 12, 13 to 18, and so on. So the frequencies in each category, we are going to put the tallies in a similar way like we did for the ungrouped data. It is just here that we know that the lowest score here is 1 and the highest is 35 or 36. Accordingly, we have made categories because we have to ensure that how we are going to categorize, how we are going to put these categories. There should not be so many It should be as per the lowest and the highest that we are going to calculate the range, and accordingly we classify into groups. So say for example, in 1 to 6 there are 3 frequencies, so we are going to put the tally of 3. In 7 to 12 we have 8 frequency, so we are going to put, like, say for example, 4 across and then 3, so this is total 8 tallies. So this is the way we are going to compute the tallies for the grouped frequency distribution. Now in the cumulative frequency distribution, it is how we calculate. Say for example, we have these set of scores: 36, 48, 54, 92, 57, 63, 66, 76, 66 and 88. So we know that this is the set of scores, and we have to plot the cumulative frequency, the percentage, and the cumulative frequency, the cumulative percentage frequency. Now we are, since this is the raw data, now we are going to have it in groups. So the lowest being 36, the highest being 92. Here what is happening is, first we need to classify them into groups. For example, we can make groups on the basis of what the score is. So the groups are like 34 to 44, 35 to 44, then 45 to 54, 55 to 64, and so on. So because here we see the lowest is 36, so this will fall under 35 to 44, the highest being 92, which will fall between 85 to 94. So accordingly, whatever the data is, whatever the raw data is, accordingly we are going to classify the groups. And the frequency is, say for example, if we go from below 1, 2, 2, 2 and so on. So we will calculate how many frequencies are falling in each. So this is the lower value and the upper value. Say for this is age in years, for example, right? And this is the frequency. The total number of scores that we have here is 10, right? Now when we are calculating cumulative frequency, so cumulative is, we are going to add the frequencies. So if we see the frequency from below, it is like 1. So the cumulative frequency will be 1. In the next 45 to 54 range, 1 plus 2 will be 3 in the cumulative frequency. So whatever the frequencies are down below that class interval, we are going to add it up. And in similar, 3 plus 2 will give us 5, 5 plus 2 will give us 7, 7 plus 2 will give us 9, and 9 plus 1 will give us 10. So the maximum will be 10 because our n is also 10. So that is one way of cross-checking. Now, what is the percentage? We are going to calculate the percentage. So what is a percentage? Whenever we are calculating the percentage, it is on 100. So this will be the 1% of 10 will be 10% to, when see the frequency. Now we are going to calculate the percentage on the basis of the frequency, right? So the frequency, the percentage of the frequency 1 on 10. So this will be 10%. Similarly, 2 will be 20%. Again, 2 will be 20% and so on. While as the cumulative percentage frequency, here you see, now again cumulative, here what it is reflecting, we are going to summate whatever the frequencies are down below plus with that class interval. So we have, if you see the percentage column, it is 10. So we start from down below, because the maximum will be on the uppermost, that is the last class interval, that is 85 to 94. So there it should be 100%, right? So here what we are going to do, so 10 will be reflected as 10 because this is starting point. Then 10 plus 20 will be 30. If you see on the cumulative percentage frequency column, 30 plus 20 will be 50 and so on. So the last will be 100. So cumulative frequency, calculating the percentage, and on that basis cumulative percentage frequency is calculated. So these aspects are important because we can have the raw data. The raw data is then classified into groups, into categories for our convenience to interpret. then accordingly the number of scores, that is the frequency, is reflected against each classification, and accordingly we can calculate cumulative frequency followed by the percentage and then the cumulative frequency, cumulative percentage frequency. So now it must be clear about how we classify data, how we tabulate them, what is important. And before coming on to percentile and percentile ranks, it is important for us to know that this classification of the categories is also on one of the bases is inclusive group and the exclusive group. Now the inclusive group and exclusive group is how we are going to, for example, 1 to 6, this is an inclusive group categorization, this is the inclusive method, while as the exclusive method can be, say for example, 10 to 20, 20 to 30. So this is how we classify the class intervals also. So there is also one method of classification of class intervals, that is as per the exclusive method and the inclusive method. This is important because according to it only we are going to compute the frequency distribution. Now, coming on to the percentile and percentile ranks, it is very important that you must have come across this terminology, this term. So, what is percentile? You must have seen that the common aptitude test, and there are so many tests, they come out with the percentile. So, what exactly is percentile? Percentile is different from percentage. And say for example, if a person has got a percentile of 10, so that means 10% of the cases lie below that person. The performance is like that, and 90% are above that performance. So it is actually, it categorizes into above and below groups. And there is no 0 percentile, there is no 100 percentile. And this is the formula on the screen that shows how we can calculate the percentile. It is the lower limit of the percentile class, or the class where the percentile may lie. This we need to calculate, and then accordingly we can put all the figures into it. P is, of course, the small p is the number of percentile for which calculation is to be carried out. N is the total number of frequencies. We need to know the frequencies also. Then the total of the frequencies that exist before the percentile class, that is F. Small f will be the frequency of the percentile class, and small I will be the size of the class interval. So these requirements are there in order to compute the percentile, and this is the formula. So in percentile also, the 25th percentile, say for example P25, this will be the first quartile, and then 50th percentile is equal to median. 75th percentile will be the third quartile, and so in a way we can say the difference between P25 and P75, that is the first and the third quartile, will give us the interquartile range. Similarly, we also have decile into it, like from D1, so it is D1 to D10. So the D1 is the 10% of the, D10 is the 10% of the cases, D20 is the 20% cases, D30 will be 30%. So that is decile. It is a group of 10-10, and on the basis of this we can calculate the percentile. Now, the percentile is actually the relative position, in a way we can say that, and it is not the individual's actual score, right? And percentile rank, similarly, it is also on a continuum of 1 to 100, and the percentile rank of a score refers to the percentage of scores in its frequency distribution. So there is some difference to it, though at times they are also used interchangeably, but the percentile rank of a score refers to the percentage of scores in its frequency distribution that are lower than it or equal to it. So it will be, percentile rank will be, for example, 100 minus 100R, that is the rank position, minus 50 divided by n, and n will be the total number of people. So percentile is most often used, but there are of course advantages and disadvantages to all in calculating the percentile rank and percentile, because it doesn't give the right score. But of course we come to know how many what is the group that lies below the score. Say for example, if a person has got 80%, but we don't know how many people fall under that score, and then in that case percentile will be of help. So in this session, if we summate what we have learned in this session, it will be like, for example, we have learned how to classify data, how to tabulate data, and what is percentile and percentile rank. Thank you.